Okay, so our equation for kinetic energy is 1/2 mv squared. Now, kinetic energy is a measurement of what? Temperature. Everything within a system has the same temperature if it's in equilibrium. So your desktop, the floor, everything in here has the same temperature, which means it has the same what? Kinetic energy. But not all things have the same mass, do they? So that means that they don't all have the same velocity either. So if we have two gases in a container, and they have different masses, that means that they have different what? Velocities. So we have kinetic energy of A equals kinetic energy of B. Two gases, same kinetic energy, same temperature. What's the equation for kinetic energy? 1/2 m of the A and V squared of substance A will equal that, right? How can I simplify that? You guys should look up here. How can I simplify this? What if I multiply both sides by 2? What happens?
Mass and velocity is equal to mass and velocity.
Oh yeah, okay. Now, for whatever reason, your book decides to go capital. Okay, so we're going to go capital M and capital V all right. We're going to square root. Yeah. So let's get the V's on one side and the M's on the other. So how do I get the V's over on this side?
Divide by V.
Divide by what?
A squared.
What I do to one side, I got to do to the other. Okay, but I want to get the M's on that side, so what do I do?
Divide by M.
So now, what is the result? We get V of A squared over VB squared. And over here, we get
MV over M.
MB over the mass of A. Now we don't like squared, so how can we simplify that? We can square root the whole thing. If I do that to one side, I got to do that to the other, right? So I'm going to rewrite this over here as V of A squared over V of B squared equals the square root of mass of B over the square root of mass of A.
Would you not take out the square root, the squares? Because you
Oh yeah. Thank you. Thank you. That was a major mistake, but thank you for catching that. Okay. This is the equation we're after. You can see it on page 375.
They call it rate of diffusion.
Graham's law of diffusion. And instead of saying, what do they write there instead of V?
Rate of diffusion.
And is rate of diffusion, that's the rate of how fast something's moving. What is the symbol for how fast something's moving? Velocity. So you see it in your book as rate of diffusion. I'm being a little lazy or just interpreting that as velocity. So the velocity of one substance over the velocity of the other will be inverse to the mass of one as the other. Now, it's really pretty easy, but it's super easy to get confused. We are so used to things being directly proportional that this one's going to drive us nuts. Because, let's go back over to here. If we have a big mass, and we're equal to this side, so that's a smaller mass, what happens to our velocity over here? A big mass means a
Smaller velocity.
small velocity. And a little mass means a big velocity for it to be equal. So what do you notice? Here we have A over B, but over here we have
V over A.
B over A. All right. Which leads us to some fun math and confusing math. So for example, if we have hydrogen and oxygen, and we were figuring out how fast they were going, who would go faster?
Hydrogen.
Hydrogen. Why?
Because it's smaller.
because it's smaller. So part of what will help you doing the calculations here is ask yourself, what makes sense? Because the bigger they are, the slower they go. Or the smaller they are, the faster they go. And that is it. You can stop the video.